Hello everyone. Welcome back to my embedded school. If you worked with a microcontroller like Arduino before, you already know how a CPU works. It runs code, one instruction at a time, step by step, very fast. An FPGA is completely different. There is no code running inside it. There is no instruction pointer moving. Instead, the FPGA physically becomes the circuit you designed. That's the biggest reason FPGAs feel confusing. We keep trying to think of them like a CPU running a program. Today, we throw that idea away completely, and we build the understanding from zero, starting from the smallest, simplest building block, and going up step by step until we understand a full real chip. We'll use a real chip as our example, the Renesas Forge FPGA. But everything we learn here applies to every FPGA in the world. Let's start from the very beginning. What does a digital circuit even need? Before LUTs, before flip-flops, let's remind ourselves what a digital circuit actually does. At the lowest level, every digital circuit takes some inputs, zeros and ones, and produces outputs, also zeros and ones. That's it. A calculator, a phone processor, this FPGA, all of it is just inputs go in, some rule decides the output. Traditionally, we build that rule using logic gates. And gates, not gates, physical transistor circuits soldered together in a fixed pattern. Here's the key limitation. Once a chip is manufactured with fixed gates wired in a certain way, that wiring can never change. If you want a different circuit, you need a different chip. This is exactly the problem an FPGA is built to solve. Keep this problem in your head. Fixed wiring can't change, because every single block we study today exists to solve some version of this problem. Part 1. LUT. Solving logic that can change. Imagine a factory made a chip with a fixed AND gate between pin 1 and pin 2. If your project actually needed an OR gate there instead, too bad. You'd need a brand new chip. So the question the FPGA designers asked was, can we build one piece of hardware that can behave like any logic function and switch between them whenever we want? Here's the clever trick. Instead of physically building an NIS or ONIS into the hardware, what if we just write down the answer for every possible input combination, store those answers in a small memory, and simply look them up when needed? Let's slow down on this with a real, tiny example. Suppose you have just two inputs, A and B. There are only 4 possible combinations, 0, 0, 0, 1, 1, 0, 1, 1. For any two input logic function you can imagine, and or XOR, whatever, there are only 4 possible answers to store. If today you store 0, 0, 0, 1 in those 4 slots, this little memory behaves exactly like an AND gate. If tomorrow you erase it and store 0, 1, 1, 1, the exact same hardware now behaves like an OR gate. Nothing physically changed, only the stored data changed. That is the entire magic trick of an FPGA in one sentence. This little memory, the thing storing answers for every input combination, is called a LUT. Look up